Hello everyone, myself Arunima Choudhury, a faculty member in the Department of Statistics at Durham College. In a brief and informative talk today, I will delve into the interesting topic of measures of dispersion. Dispersion refers to the extent to which values in a dataset deviate from their average. It measures the variability or spread of data points, providing insights into the distribution's overall shape. An ideal measure of dispersion should have the following characteristics. It should be rigidly defined. It should be easy to understand and easy to calculate. It should be based upon all the observations. It should be amenable for further mathematical treatment. It should be least affected by fluctuation of sampling. Following are the different measures of dispersion that are in common use. Number 1, range, quartile deviation or semi-interquartile range, mean deviation, standard deviation. Range. Range is like finding how much your numbers stretch. You just subtract the smallest number from the biggest one in your group, and that's your range. For example, if the observations are 2, 9, 4, 3, 10, 5, 1, the range is 10 minus 1, that is 9. Here are some merits and demerits of range. Merits. It is easy to understand and easy to calculate. It is rigidly defined. Demerits. It is not based upon all the observations. It is affected much by the fluctuation of sampling. It is not amenable for further mathematical treatment. Quartile deviation or semi-interquartile range. It is defined as half of the distance between the third and the first quartiles. Symbolically, quartile deviation is given by this formula. One of the most important characteristics is that it gives an idea about the variation of about 50% of observations around the median for distributions which are not too highly skewed. Merits and demerits of semi-interquartile range. Merits. It is rigidly defined. It is easy to understand and easy to calculate. Demerits. It is not based upon all the observations. It is not amenable for further mathematical treatment. Mean deviation. Mean deviation is a way to see how spread out numbers are in a group. You take the average of the distances between each number and the mean of the whole bunch. It tells you, on average, how far each number is from mean. Mathematically, mean deviation is given by the following formulas. Merits and demerits of mean deviation. Merits. Mean deviation is rigidly defined and easy to understand and calculate. It is less affected by extreme observations. Demerits. It is rarely used in sociological studies. It cannot be computed for distributions with open class. Please refer to the illustration below for the mathematical details. Standard deviation. Standard deviation is like a more user-friendly version of variance. Variance is a measure of how much individual numbers in a group differ from the average. You find the average, then see how far each number is from that average. Square those differences, add them up, and divide by the total number of values. It gives you a sense of how spread out the numbers are. Mathematically, standard deviation is given by the following formulas. Here are some properties of standard deviation. Number 1. Standard deviation is independent of change of origin but not of scale. If the number of observation, means, and standard deviation of two classes are n1, n2, x1 bar, x2 bar, and sigma 1, sigma 2 respectively, then the standard deviation of the combined series is given by this formula, where d1 equal to x1 bar minus x bar and d2 equal to x2 bar minus x bar, and x bar is given by this formula. Please refer to the illustration below for the mathematical details. Merits and demerits of standard deviation. Merits. It is rigidly defined. It is based upon all the observations. It is amenable for further mathematical treatment. It is least affected by the fluctuation of sampling. Demerits. It is not easy to understand and not easy to calculate.